Hello, and welcome everyone to this exciting webinar, Unveiling the Importance of Android Root in Mobile App Security. My name is Zoe Gardner, and I will be your host this morning. A few things to note before we get started. Can I ask a few of you to raise your hand to verify that everyone can hear us? Thank you, Sheng. Excellent. Listeners are automatically on mute for the webinar. If you have a question, please write it in the chat. If we don't get to your question during our session today, we will follow up with you immediately after. Joining us today is Sam Mott, UK security consultant at LRQA Nettitude. Sam, please say hello to our listeners.
Hello, nice to meet everyone.
Great. Also joining us today is Sheng, lead DevSecOps solutions at Appdome. Sheng.
Hello, everyone.
Okay,
Hello,
great.
everyone.
Welcome to you both. Let me go ahead and set up the problem we're here to discuss today. In the dynamic world of Android devices, understanding the intricacies of rooting the Android operating system and root detection has become crucial for both developers and security professionals. With new tools on the scene like Magisk, Zygis, and others, Android root has evolved into a hot topic in mobile app development and DevSecOps. In this webinar, Sam Mott and Sheen will discuss the crucial role of Android root in mobile app security, showcasing Android root from the standpoint of the pen tester. Sheng, I understand that you're going to start us off and explain a little bit about Android root and also the crucial role that Android root can play in mobile app security. Later, too, you'll show how Appdome can solve these problems.
Yeah, thank you so much, Zoe, and welcome everyone. Good morning, good afternoon, good evening. I know we have people all around the world here, so very excited to meet everyone, to discuss with everyone on some crucial aspects of mobile app security and the evolving landscape of threat prevention. Matthew, I do see you with your hands up. You can put your hand down if you like. And thanks for everyone for joining us, and I really appreciate your time. So let's dive right in. So what are we going to talk about? We're going to do a quick overview of, again, kind of the evolving landscape of what's going on today. We'll go into the definition of Android root, why that matters. And then my colleague here, Sam, will discuss how we took a test case and do a pen test around that, and went ahead and assessed the vulnerabilities with the Appdome protected app. And then we'll wrap it up with why Appdome, how Appdome addresses the Android root specifically, and many more different vulnerabilities. By the way, there is a Q&A button, I believe. If you want or have any questions throughout this presentation, feel free to go ahead and submit your questions there. We'll try to get those in at the end. And if not, we'll definitely follow up with you, and certainly send you an email to follow up and try to answer your questions there. Okay, so let's dive in. First, we're seeing a continued challenge of actively protecting applications while they're running. So RASP, right, runtime application, self-protection, right? So certainly that has become the norm. This involves detecting and responding to threats in real time, creating a dynamic shield around your applications. One notable challenge that we're seeing still is the persistent issue of Android root, right? So therefore, we're seeing this continued concern around Android apps with Android rooting. And of course, on the iOS side, we've got the iOS with Apple with jailbreaking, right? So certainly that seems to be a critical issue continuously. Now let's talk about the principle of shift left, right? That seems to be pretty trendy for the last, I'd say, 5-6 years now. It's about integrating security early in your software development lifecycle. DevSecOps has been a very popular term, really gaining prominence, right? Emphasizing that security should be an integral part of the development process from the very beginning. This approach ensures that security is not an afterthought, but a fundamental aspect considered at every stage of your development. API security. API security remains a top concern, especially with the increasing reliance of mobile apps on API for functionality, right? Especially, connecting to the backend, accessing that data. So this vulnerability, these type of vulnerabilities and data leaks can occur through APIs, which can certainly pose as a significant threat. So it's crucial for organizations to implement robust measures to secure their APIs. Another significant trend that we're seeing just across the cloud and infrastructure, as well as the DevSecOps world, is the zero trust model. This model is, basically you're treating every user and device as untrusted until proven otherwise, right? So you're not going to trust them until they provide you some sort of, user or device-based, credential to verify that you are who you say you are, right? And another thing that's very critical there is continuous monitoring, right? So being able to monitor and also automatically remediate as part of the some of the findings of some of those challenges and issues that you see. So the zero trust model is definitely very prominent in these days today. As we look to the next few years, we see that machine learning and AI for threat detection and prevention is on the rise. These technologies play a crucial role in identifying and responding to unusual patterns of behavior that could signal a security threat. So by leveraging the power of AI, these solutions and platforms and organizations can then enhance the ability to stay ahead of some of these cyber threats. So let's define the term root in the context of Android. So rooting is the process of gaining super user or administrative access. So you now have rights to the actual Android operating system, right? This essentially means unlocking the full potential of your device, allowing you to access and modify system files and settings that are usually typically restricted by your carrier or by the manufacturers of the phone, right? So why would someone want to root their Android device? Well, the answer is, when you root your device, then most of the advanced users then can gain the ability to install custom ROMs, remove any type of bloatware from the manufacturer, and access features that might be restricted by your carrier, right, or your vendors. So it's a way of kind of taking full control and personalizing your Android experience. However, with greater control comes greater responsibility. Apps running on rooted device can then have elevated privileges, meaning that they can access certain sensitive parts of the system, which can be a potential security risk, right? So this is what we're really trying to avoid, is that malicious apps could take advantage of these elevated privileges to carry out harmful actions with greater ease. Right? Think about, imagine, if you will, a banking application, and unknowingly to the user, if that application were potentially have malware or vulnerabilities in it, it can potentially gain access to system files or settings. And worst case, they could probably wipe out your banking account, right? So certainly we don't want that to happen, right? So, these type of vulnerabilities can put both your personal data as well as any type of corporate data and the overall integrity of the device at risk, right? So certainly very, very dangerous when it turns into the wrong hands. When a device is rooted, right? So some of the risks that are associated with rooted devices, let's dive deeper into that. Again, malicious apps can exploit the elevated privileges to carry out these harmful actions. This may involve, again, accessing sensitive data, modifying crucial system files, establishing unauthorized network connections, right? So these can be really, really, really weaken the device ability to resist any unauthorized access and compromise its integrity, right? So certainly that could be very challenging there. So regarding data exposure, Rooted devices poses significant risk there. They may exploit that to access personal information, as I mentioned, login credentials, any type of confidential data, right? Think about your patient medical data, right? Any type of healthcare data, any type of financial data, maybe data that you just don't want to be leaked out there, right? And onto the internet and to be sold on the dark web. Well, that can certainly be jeopardizing your individual privacy, and also raises concern about any type of sensitive information that should be secured. Bypassing these security measures certainly would not be good, since we're trying to secure the boot process to fortify the overall security posture. So when a device is rooted, the users can gain that ability to bypass these security measures, essentially creating vulnerabilities that could be exploited by these malicious attackers, right? So it really weakens the device's ability to secure and prevent these type of unauthorized access. So the network configuration, right? So, if they're able to get into the network, think about some of the things they can do, right? They can, travel east-west, perhaps north-south, right, across your network. They can do network-based attacks, man-in-the-middle attacks, right? The attacker can possibly intercept and alter communication between two parties. So these type of implications can certainly extend beyond the individual device and impact the broader network environment, right? So, I mean, I still think back, the Target attack years ago, where, you've got a retail point of sale device that got hacked, and all of a sudden it goes across the entire network, and that affects all of the entire retail network for Target, right? So certainly we don't want that to happen as well. So what are some of the common bypass that we see with Android root detection? Well, certainly they can try to temporarily hide or mask root access. These type of tools are designed to trick root detection tools to provide user with a temporary illusion of non-rooted status. Emulation or sandboxing, right? So by using emulators or sandbox environments, things like VMs, etc., they can simulate a non-rooted device, thereby circumventing root detection tools. And certainly, again, these can potentially be used for misuse of these methods. Custom ROMs or firmware can be present. This could be another way to bypass root detection. Customized version of the OS may alter the security measures or mask root access, allowing the user to use the rooted device without triggering detection mechanism. What about root cloaking apps, right? These are applications specifically designed to cloak the presence of root. So they're kind of unwanted, right? So these apps will try to use various techniques to deceive these root detection tools, creating a challenging kind of cat and mouse game, right, between the developers and those that are seeking to manipulate the root. So some of the real world examples of exploitation and malware, right? These are first is Ghost Push, right? This is gaining root access in older versions of Android, had the ability to install unwanted apps. In some cases, it could even root the device without the user's knowledge. Godless is another one, a malware that will run again in older versions of Android 5.1 or earlier. Right, we kind of see the pattern here, right? You probably want to try to use a later version of Android, try to keep up with the Android OS version, and especially update your applications. I know a lot of us will ignore some of the Google Play Store updates, but there's reasons to update, right? A lot of them are security updates to try to patch some of these vulnerabilities, these malicious software aimed at rooted devices, right? So the widespread use of these older Android devices made a lot of these malware and vulnerabilities existent. Ztorg is another example where they're using diverse tactics, being able to leverage root exploits, use social engineering techniques to gain over a device. And again, once rooted, they can install additional malware. They compromise the security of other applications on your device. And so again, just overall security of device has been compromised. Lastly, we have an example with Hummingbird. It's not exclusively relying on root capabilities, but it employs a rootkit to gain that access. This malware was adept at installing fraudulent apps on the device and actually generating ad click revenue, right, for the actual attackers. So certainly we don't want additional malware on our device that are generating money for other people, right? So Hummingbird really demonstrated the adaptability of malware creators in finding new ways to compromise the device integrity. Okay, I'm going to turn it over to Sam, my colleague here from Nettitude, and he's going to talk a little bit about the role of penetration testing in mobile app security.
Thanks, Sheng. So the first question people usually have when it comes to pen testing is, what is it, and why would you want to pen test in the first place? Right, and the reasons typically fall into three main categories. So first, most obvious one is you want to discover vulnerabilities in your application. So pen testers basically simulate real-world attacks using the same techniques and tools used by real-world attackers. And this allows us to potentially identify potential issues before attackers do. In fact, it's quite common for companies to integrate pen testing into their software development cycle. So that security tests are basically performed before a public release occurs, so that you can basically catch any potential issues before an attacker can take advantage of them. Another common reason is perhaps you want to get a risk assessment to see basically how your company holds up against an attack. So pen tests can establish what, if any, potential risks are associated with your applications and how they may affect your business. Pen tests can also help identify potential areas of improvement. So perhaps your app isn't following best practices or it's missing key security features. Or perhaps you're about to release a new feature and you want to understand, does it have any potential business impact in some way? Third reason is usually related to some form of compliance requirements, right? Perhaps you're dealing with credit card information and so you need to be PCI compliant. To become PCI compliant, you have to get a pen test to basically show that you're actually secure enough to handle such sensitive data. Alternatively, if you're handling any form of, say, sensitive customer data, such as their personal information, right, you need to be GDPR compliant or whatever the equivalent is based on the countries you operate in and the data you handle. Pen test is a great way to basically ensure that you're keeping compliant to minimize any potential hefty fines or legal action due to lack of due diligence. And it's also just a great way to validate existing security controls to ensure that everything's working as you expect. Next slide, please. So to ensure we're performing high quality pen tests here at Nettitude, we base our methodology on industry standards such as OWASP's MASVS, which is their mobile verification standard, and also their application verification standard, the ASVS, which we mainly use for testing the application API because it just has more test cases compared to just using the MASVS alone. Both these standards have associated testing guides, which we do supplement as needed based on years of experience and the needs of our clients. But ultimately, we aim to cover a wide range of test cases. You can see some of the broader topics being listed here. But the main focus of today's talk is, of course, on the resiliency aspects of mobile applications. So basically, how well does the application protect against an attacker, pulling it apart and figuring out how it works and if it has any vulnerabilities. Next slide, please. So to test this, Appdome provided us with two versions of the same app. One with a basic set of their protections enabled and an advanced version with some additional protections, with the clear goal being to bypass every detection. Now, when it comes to analyzing protections, OWASP poses four main questions that should be answered during the analysis. So the first of which is, can the mechanisms be bypassed trivially? How difficult is it to detect the detection logic or identify it? Do you need to write any sort of custom code to disable the defenses? And if you are able to bypass anything, how much time did it take? And through this, you can basically understand how complex the protections are and whether they're sufficient based on the threat model of your application, because each app is of course, can have different needs. Now, when approaching a reverse engineering project, it's a very complicated task, so it's important to set some clear goals. Otherwise, you're going to quickly get lost in the weeds because you just cannot realistically understand every part of an application within a reasonable amount of time. So some focus is needed. Now, we'll get into some of the strategies I use during the test, but at a very high level, the strategy is to basically, try well-known bypasses first, monitor a bunch of functions to see what the app is doing, and then filter the results and focus on what's important. Next slide, please. So like I said, the first approach was to basically check all of the common well-known bypasses because, pretty much all attackers, when they first encounter root detection, they're going to go for the lazy approach and they're going to try one of these, most likely. And there are other solutions available, but they're either deprecated or no longer maintained or whatever else, right? So these are the latest techniques that are being used. And they tend to work in most cases. Most apps are using open source protections like root beer, for example. But of course, in Appdome's case, it didn't work. Their solution successfully blocked all these attempts, which gives us a nice baseline to work from, and clearly indicates that they're doing more to block rooted devices. Next slide, please. So when it comes to performing more in-depth analysis, we commonly take advantage of Frida during a pen test. It's essentially a dynamic instrumentation frame toolkit. It basically allows us to do rapid R&D during our reverse engineering projects because it makes it very easy to hook into the application and modify its behavior, detect what it's doing, and so on and so forth. So when it comes to analyzing root detection logic, there's a bunch of things you look into, some of which are listed here. But the general idea is to basically hook into various functions, methods, classes, and so on that are commonly used by root detection solutions to basically try and figure out where and how the check's being performed. So for example, nearly all root detection solutions are basically check for routing related artifacts on the device. So for example, most rooted devices have the super user binary somewhere on the system. And so it's usually a safe bet that if you can hook functions like say open or lstat, right, it'll point us in the right direction. Now, the same method was used for all the other strategies listed here. Actually, wait, could you go? Yeah, thanks.
Sorry about that.
No worries. So yeah, the same method was basically used for all the other strategies listed here. So basically, I was trying to spread a wide net across the application to try and see what it's doing, which the white paper goes into more detail on. And in some instances, I did identify that Appdome was performing the expected checks. So for example, checking for super user binary, right? However, even when I overwrote those checks in an attempt to bypass them, it just wasn't enough to bypass the solution as a whole. It turns out that the main hurdle was definitely the integrity checks. So whenever I patch the application, it would basically detect that it's been tampered with at runtime and forcibly close the application. Now, I did attempt to investigate that avenue further, but there was just extensive obfuscation techniques being used. That's just making a real pain to actually figure out what was going on. And on top of that, there's also anti-debugger checks, which is, again, making life difficult as a reverse engineer. Now, I did also try to attempt to basically intercept the app's lifecycle and sort of hook some low-level functions to prevent it from closing the application because, one method to bypass is to basically ignore all the checks being performed and look at what it's doing at the end. So if it's closing the app, maybe you can stop the application from closing and bypass it that way. But I wasn't able to do that. It seems like it's a close-kept secret at Appdome how they actually prevent or how they close the application forcibly, which you wouldn't tell me, but so I'm still unsure how they do that. Next slide, please. So ultimately, I was unable to bypass the root detection within the allotted time periods. As I stated before, all the classic solutions failed, mainly due to the robust integrity checks. So a lot more time is going to be needed to make any substantial progress in reversing the application. It's clear that an attacker would need to be an experienced reverse engineer to tackle Appdome's protections, which, to be honest, rules out the majority of attackers because they're primarily opportunistic and looking for easier targets in most cases. It should also be noted that I was only testing a smaller subset of Appdome's potential protections too. There are a lot more options you can enable to further increase the difficulty. For example, one of the things I did during the test was basically dump the application's memory to search for any interesting strings and basically discover what sort of artifacts the application may be searching for example, right? But to counter that, Appdome has memory encryption available to prevent that avenue. It just goes to show that it's just a constant cat and mouse game, as Sheng mentioned. As new analysis techniques are found, new counters are created to make it more difficult. Because at the end of the day, reverse engineering is just a psychological battle, right? If you make things difficult enough, nearly all attackers are going to give up and eventually move on. Yeah, back to you, Sheng.
All right, thank you so much, Sam. And as Sam mentioned, we did create a white paper as a summary of some of the items that Sam mentioned as he went through the test. So if you're interested in that, we will be following up and sending out an email to everyone that attended this. So, look forward to that. That has all the details of some of the interesting bypass scripts that Sam had tried to use in his limited time to test against this app. So again, thank you so much, Sam, for doing that. And hopefully the white paper will discuss in more detail if you're interested in some of the details on how Sam did that. So let's talk a little bit about how do we remediate some of these root findings through automation. So Appdome allows for a seamless integration of RASP solutions into your app, enabling it to detect and respond to suspicious activities in real time. This will include a crucial capability of identifying root-related behaviors and take immediate action to both apps and sensitive data by actively monitoring and responding during runtime. So RAP becomes a powerful ally in this ongoing battle against the kind of the cat and mouse game against the attackers, right? So root detection. So Appdome also protects against root devices specifically. So root detection is a valuable feature provided by Appdome. With Appdome, you can integrate root detection mechanisms as simply as just enabling it in the console or via our API. We also have plugins if you're happening to use any of your CI/CD tools like Jenkins or GitHub, GitLab, Harness, Circle CI, right? These are all tools where we have plugins where you can actually just call the plugin and enable root detection or iOS jailbreak if you're on iOS, and it can then detect if the application is running on a rooted device automatically, right? Again, no code, no development to do that. It can take those predefined actions and certainly try to safeguard your security. So these actions can then, if you want to, you can perhaps implement what we call threat events, which I'll talk about here in a few slides here, which can then disable certain features, notify users about potential risk associated with running the app on a rooted device. You can even log it and notify the administrator. So these type of proactive approach can mitigate the security risk posed by a rooted device. Now, what sets Appdome apart from some of its competitors, or if you were to do it yourself, is that there's no code integration process, right? So this means developers can add the security without delving into the intricacies of implementing security code for mobile apps. So this ease of integration becomes a significant advantage, especially when you're building out an application where you're spending a lot of time in building the application itself and really don't have the time to be concerned about the security aspect of protecting that application, right? So, and security is very, it is a different field as well. For those of you that are focused on security, know that it does require some complex manual coding or perhaps extensive modification to original app, where truthfully, as a developer, you may not know how to implement some of those security features, right? So, I think many of the survey customers that we went out and questioned, what are some of the biggest challenges that they see once they see the findings? Well, it's actually implementing the actual remediation and the protection that they need to do. So 9 times out of 10, they end up not doing it or pushing it out a year or two, which can be very, very critical and could be a big loophole for attackers, right, to attack against. So certainly that could be an issue. I mentioned threat events. So threat events is a solution offered by Appdome. It's a powerful tool during the security integration process. You can enable this on the console or via API. This provides a proactive approach to threat detection or response, and not only detects root detection, but it also detects other security threats. We do support up to 160 plus different protections, and out of those, many of them you can actually detect when it happens. So during this security integration process, threat events can be configured to keep a vigilant eye on your application's environment When a rooted access is detected or any type of threat is detected and an event is triggered within the app, it does this automatically as long as you have Appdome running, and it will then signal the potential of a compromise of the security. So the implementation of the response, this is something that could be customized as by you as the developer, right? So when this gets triggered by root detection, for example, you can design the action to take. So you can say, you can display a message, a warning message to your users about the potential security risks of running on a rooted device. Making sure that you're transparent with the user. Maybe you don't want to support it, right? You want to go ahead and say, hey, we're going to close down your app graciously because you're running on a rooted device. Now, I'll add that most competitors, they'll go ahead and just crash the app, right? Because it's not very easy to graciously close out the application. So that's something that Appdome provides as well, where you can graciously put out a warning message and then go ahead and graciously close out the app. Additionally, you could continue to allow them to run the application, but maybe you want to disable certain sensitive functionalities inside of your application to restrict access to critical data, mitigating that impact of a security breach. Finally, in the event of a security breach triggered by this root access, your app can also log the incident, which will allow you to have a record or audit for further forensic analysis, right? And this can also be pertinent if you're using an AI type of analytic or threat detection type of engine. It can then go into that to potentially sync those into other type of attacks and to give you a more holistic view of what's going on with the attacker and the threats that occurs. So how do you use threat events? Very simple. You would, again, you look at the list of the threat events that's available. You understand the metadata, the type of parameters that you want to, kind of listen into or get triggered or get alerts or triggered by these events. And then you go ahead and implement the actual proactive actions that you want to take inside of your application, right? So there is some coding here. I know I said this is no code, but to actually implement the proactive action, that is up to you as the developer to implement how you want to, restrict or limit the security breach of a rooted device, right? So here's an example of how companies use Appdome's threat events to customize the messages when the security event occurred to create a greater user experience. So these examples show warning messages for when root detection occurs. And this is where, again, you want to be transparent to the user. By the way, we have a reference code that you can tie into. So if the user does get this reference code and decide to code into your help center or your support center, we can actually tie that reference code back to the actual application, so you can actually see exactly what the users are seeing, right? So this is something that, again, allows you to have better visibility into the application. As Sam mentioned, there are other open source tools out there like root beer, with other open source tools like root cloak, safety net helper from Google, root checker. These are all have been very pivotal, right, in the cat and mouse games we mentioned of root detection on Android devices. However, it's very important to recognize that these tools might not be very comprehensive in identifying all forms of root access or root cloaking or root hidden methods used to conceal it. So certainly, these evolving nature of root access methods creates a challenge for these tools to stay ahead of these emerging threats. Now, you may ask, well, why can't I just go ahead and develop this in-house, right? Why can't I just remediate and implement some of these security solutions in-house? A lot of us do, right? While it may be tempting to develop this a proprietary mechanism to do root detection, to do encryption of your application, and to detect for man-in-the-middle attack, to detect for Magisk or Zygis or Frida, et cetera, right? Again, 160 type of protections that Appdome provides. Now, you could try to mimic that, but the investment of time, developer resources, the ongoing maintenance of this code, right, is very, very substantial, right? So really ensuring that same level of quality, the level of protection, the continuous update, that certainly will become a very challenge, right? You're not in the business of protecting your application. You're in the business of developing an application with the business logic that can make you more money, right? So certainly, this is where Appdome's solution can really assist in your organization. So Appdome not only offers continuous updates, right? We have a research team that continuously monitors the security landscape, research any type of evolving threats, so that we can provide a comprehensive security offering. This platform integrates multiple layers of security features, combining various protections all in one place. So it saves you time, effort, compared to developing and maintaining this yourself. So most importantly, I think, is the fastest time to market for your application. And this can be huge. I work in the insurance industry for many, many years, and I can see that putting your product out there takes usually 3 to 6 months at least, right? So if you kind of add that on to adding in even more time to securing the application, which could take another 3 to 6 months, that's certainly not the time that you can afford. So Appdome stands out as the ultimate one-stop shop for mobile app defense, offering a comprehensive suite of features to fortify your application. With this built to protect automation platform, Appdome simplifies the integration of security, allowing developers to add robust protection without delving into complex coding. The certified secure feature also ensures security protection are not just added, but certified, meeting the highest standards of, for security. And Appdome's threat events, as I mentioned, keeps you informed about potential threats and triggering alerts and proactively, right? And this is very important, is you want to kind of stay ahead of the game, right? Proactively restrict access and limit security access when necessary. And lastly, we do have a product threat scope that will feature monitoring or management of both protected and unprotected threats. So we can actually see what threats are actually occurring in real time. It does this through an agentless architecture and providing you a continuous monitoring against emerging security risks. So we have some really, really interesting data across the globe, across our customers, right? So in this rapidly evolving threat landscape, Appdome serves as a vigilant guardian, empowering developers to fortify their mobile apps with confidence. So as a recommended next step, I would suggest to engage with both Nettitude and Appdome. We call it discover and remediate. So Nettitude can run the pen test to discover these vulnerability and malware. We can then use Appdome to remediate some of these findings. And then you may want to prioritize some of these remediation, right? And then you may want to have Nettitude to run that pen test again after we include the Appdome protections, so you can validate some of those protections are being made, right? So certainly this will then allow you to enhance your mobile app security by addressing any type of identified vulnerability that Nettitude have discovered with Appdome's comprehensive protection measures. All right, thank you very much. And Zoe, do we have any questions that?
Yeah, no, that was a ton of fantastic information, Sheng and Sam. Really, I think people must have learned a lot about Android root, and we're getting a lot of questions. I know we only have time for a few of them, so I'm going to go ahead and ask you, Sam, one of these first questions that came in. How does a manual pen test compare to an automated mass test?
Sure. So good question. So the Well, I'll go with the pros and cons, I guess. So the pros of an automated solution is usually it's cheaper. First of all, it's a lot cheaper than a manual pen test, and you usually can do it at any point you want. You can just last minute just be like, oh, I need a security test, fire it over to an automated solution, and it will spell out some answers. The downsides, though, is that usually it spits out a bunch of false negatives or false positives. So you'll have to take the time to basically filter through the outputs to figure out what's actually relevant to you or not. It's also hard to prioritize the findings as well, because again, maybe there's a lot of false positives. You need to filter through that. It's also not great at finding complex issues. So, for example, business logic and such, which is unique to each app. And also testing the API is also another very sticky situation, I guess you could say, because like there could be, say, third-party web services that are being used, or web APIs and such are being used, and you don't want them to go off and just randomly start testing third parties, because that could cause legal issues. They're also not that great at performing complex bypasses if you're testing specifically the resiliency aspects of your product. And also, it's just it's not that great at testing native libraries if you have those in your applications and such. So usually manual pen tests can actually dive much deeper into your application, and that can actually work with you as well. So if you wanted to prioritize certain aspects of your application, so perhaps you have a brand new feature that's going to come out and you say, oh, we want to test this specific flow, and automated solution is not great for that because it doesn't really understand your application well enough to be like, okay, I'm going to test this specific flow, whereas a person will. So
yeah, I think that's a great point about prioritization, because how is an automated test going to understand that new feature being of utmost importance?
yeah.
Awesome. Okay, and Sheng, another question came in. Why bother with a pen test when I can use Appdome's solution to protect me?
Yeah, that's a great question, right? So one is we want to use a pen test to perhaps complement what we're adding into Appdome, right? So as security breaches and these malwares evolve, we're continuing to see new things that perhaps Appdome have not seen, right? So certainly we want to make sure that Appdome's always up to date. So pen tests can also can kind of keep us honest there, right? So certainly that could be a huge compliment. And also, a lot of times what we see is customers are doing a pen test beforehand, before coming to Appdome. So this is where you can get a quicker understanding of how bad is your application in general, right? So how susceptible is it to breaches? So certainly that's something I would definitely recommend to customers. Doing a pen test first to get a feeling of how much work you need to invest into this. So I would say is doing a pen test is kind of give you an assessment, just like buying a house, right? So a lot of times we want to kind of do an inspection first before we actually go all in on a solution, right? So a pen test would be a very good solution for that.
Yeah, I think both Appdome and Nettitude play really well with each other in terms of they each kind of leverage off of the other and help provide an optimal solution for both the business and the end user as a result. Okay, I think we have time. Let's do one more question, and then like Sheng mentioned and I mentioned earlier, we'll follow up with all the remaining questions that we didn't get to today. But this one goes back to you, Sam. What's the biggest challenge you see in remediating the pen test findings from the pen tester side?
So I think it would yeah, I think it would depend on the findings themselves, right? So when we perform pen tests, we try and provide a lot of remediation advice of like how you can basically take this finding and how you can remediate it successfully. However, some findings are a lot more complex. For example, like root detection, for example, is a very complex issue to remediate. And so, like Sheng mentioned during the presentation, developing your own in-house solution takes a lot of effort to do, right? It's going to take a lot more money and a lot more time to actually develop your own custom solution. I mean, if you wanted to do it yourself, you'd be hiring a whole team of experts to do it, right? And when you add up all the salaries and all the additional costs, right, it's very expensive. Whereas Appdome has an available, ready-made solution available. It's very easy to integrate into your current current system and such. So, yeah, I think using Appdome to solve that issue is a lot simpler overall.
Well, awesome. I think that's all we have time for today. Sam or Sheng, I would like to offer you guys any closing remarks.
No, just thank you very much for joining. I know time is precious in our world, so thanks everyone. I see quite a few companies that have registered. I'm glad to see we have a pretty good turnout here.
Yeah, thank you everyone for your time. I hope you enjoyed the presentation, and hope you enjoyed the white paper as well.
Awesome. Okay, everyone, that's a wrap. If you're interested in learning more about LRQA, Nettitude, or Appdome, please visit each company's website. We'll be doing more of these in the future to help creating secure mobile applications better and easier for everyone. Like this video or share it with a friend when we share the recording with you. Thank you so much again, and have a great day. Bye-bye.